All these students, let's try to understand the units and dimension party. You see, the length is measured in meters, symbol is m. See the second row, mass measured in kilogram and symbol is kg. Similarly, time, second, symbol is s. Electric current will measure in ampere, A. Luminous intensity in candela, CD. Temperature in degree Kelvin, K. And the amount of substance is a mole, and symbol is MOL. Similarly, you can see the plane angle and solid angle. It is measured radian and radian, symbol radian, SR. Well, the students derived units, they are physical quantities also. So their units will measure force measured in Newton, symbol is N. Work energy can be used as joule, capital J. Power in the watt, and the symbol is W. Similarly, in the fourth row you can see the electric charge measured in coulomb, symbol is C. Electric potential volt, V. Electric resistance ohm, symbol is, you can see there. Frequency Hertz, symbol is SZ. Magnetic flux Weber, WB. And magnetic induction can measure as Tesla, T. Yeah. Hey students, let's try to understand what are dimensions. What are dimensions? Are they important? How do you find? Let's define them. Dimension of physical quantities are defined as the power to which the fundamental units are raised to obtain the unit of that quantity. The unit of length is denoted by capital M, mass by capital M, and time by capital T. Okay, that is, we always represent dimension in square bracket as shown there. Please do not use any other symbols. Okay, so for you will write in the bracket M, L, and T with the powers A, B, and C. These represent dimensions of any physical quantity. Hey, let's try to find out. Yeah. Okay, let's try to understand how to find the dimension of some physical quantities. Yeah, let's go. Okay, dear students, let's try to understand the how to find dimension of any given physical quantity. To begin with, let's take very simplest one. Say example is length. Okay, length means you can just write a simple, you can measure centimeter, etc. A simple L. That's all, nothing more than that, right? How do I refer to this a dimension? Very simple. I use my square bracket. Okay, this is the normally how you find. We'll use the say length as L. Okay, so we have three quantity written as M, L, and T in this square bracket, right? While writing it, you see there's no mass content, there's no mass in the length, only length is there. So there's no mass, we'll put A is equal, M is equal to 0. That is as shown to earlier as A is equal to 0. Then you write, because this L only once time, so power is 1, so we write as 1, right? And there's no time component here in the length. In the length there's no time component, so we'll write, so if there's no, I write this is equal to C. This is a simple way I can find the dimension of length. Okay, let's try for next, very simple one, another one. Let's take as a mass. Yeah. So the mass can be written as very simple, simple M, which is normally measured in grams and kilogram, etc. So how I'm going to write? So mass is just mass, nothing more than that, right? So how I'm going to write? So same thing, M, L, and T. So let's find out. Since there's mass only once, we write 1. Similarly, we don't have any length component here, so we write 0. Your B is 0. Similarly, there's no time component, the C is 0. So this becomes the dimension of length and mass. Let's try one more. Time. How do we measure the time? Yes, in second, of course. So we write this as T. Okay, let's go. You see, when I'm measuring in time in seconds, maybe in hours or whatever the unit you feel it, good. But it is to be just a simple time E. Okay, so you get M, L, and T. Okay, if you see in the time definitions, there's no mass component, so A becomes 0. There's no component of length, so L becomes 0, but time is 1, there's component 1, so we write 1. As simple is what you can understand. Okay, since we understood how to find the dimension of length, mass, and time as reflected here, let's try for little higher physical quantities. Let's begin with say area. Okay, let's go to area. How do we find area? Very simple, we say length into breadth. Okay, right. So we'll take it down. What is the length? Is L only. What is the breadth? Is as good as length only. Okay, length multiplied by length. Normally find the area of this. So this becomes nothing but L square, right? L square. So it will become like this. How? You write M, L, and T. You see what you get? Now if you see in this area, you don't have component mass, so A becomes 0. But the power of length, that is the length is 2. So we write B is equal to the power raised to which physical raised to power of 2, that is length raised to 2, and there's no time component, that is 0. I hope you understood very clearly. Let's try one more. of that volume. Okay, how do you define the volume? Yes, it is length, breadth into height, right? Again, the length is measured in L, breadth is also a length, and time is the height is also in length. So in all this we get L1, 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 so you get power to 3. Now definitely I think your guess will be very much right. What should be your dimension of volume? So we write M, L and T, right? So since there's no mass component here, so A becomes 0, that mass becomes 0, but length is power to 3, we write 3, and since there's no time component, 0. Okay, this completes our volume. Okay, let's go back to the beginning. Okay, you see, first we describe the dimensional length is L, and we write M, L, T, and make sure that this bracket should be always a square. Do not use any other type of bracket, please. Okay, since the length is only one's length, so if we M, L, T, the component has no mass component becomes 0. The length is repeated only once, or the to the power number, so L1. See, there's no time here, component write T is equal to 0. Okay, similarly mass, you see, there's only component of mass is here, remain all both the component of time and length, and time is 0, so it is 0. Similar time, you see, time component is raised to power 1, remaining the mass and the length components are 0. Similarly, try to find the area of area dimension of area is the length and breadth. So breadth is also written length L square. So we get M, L, T. M is power to 0 y because there's no mass component. L is here, L is twice, so we get 2, and time is 0. Similarly, found the also volume, right? Let's go for one more before we wind up for this session to begin with dimension next session. Let's try to understand. So we'll take a very simple one as velocity. Okay, how you define velocity? You can take a symbol V. Velocity can be defined as displacement upon time. We can define this as displacement upon time. Okay, so displacement normally it is can take a length as well as L. Displacement is length. How far is it displaced? 1 meter, 2 meter, and time is taken as T. If you see this again, okay, I'll take it here. So L is 1 definitely, but if the T is in denominator is a power to 1. If I take this up, it becomes T raised to minus 1. As simple as it, right? So what should be my dimension now? Again, I open up the square bracket with M, L and T. Okay, and close the square bracket. Now let's find for mass component. There's no mass component, we write 0 here. Length repeated once, we write L1, and time is my inverse of 1, that's minus 1, so we write as minus 1. This fake say okay, length upon time, displacement upon time. That is how we get the dimension of velocity. Since we already understood how to
thanks, we'll meet again, stay connected.